I'm Emma Chenoweth of Chemical Watch, and I'll be moderating the event. But before I hand over to Amy Klinger from PETA, who will introduce the event and speakers, I'd just like to run through the format. Today we've got two speakers who will jointly present their slides in just about an hour's time they'll take, and then we'll go to about a 20-minute Q&A session. Now, all delegates can ask questions during the webinar by using the questions box on their screens. Send your questions as early as possible, and then we can forward them to the speakers in good time. Also, if your questions aren't answered during the webinar, then you can submit them to our forum, where we'll deal with them there. We'll provide the link to the forum at the end of the webinar. If you experience any technical problems during the webinar, you can also use the question box to send a query to my colleague Lorna, who should be able to help you. So if your sound's not good, or if there are any other problems, just get in touch with Lorna. And delegates should also know that a recording of the webinar, along with all the slides, will be available on the Chemical Watch and also the PETA International Science Consortium websites for the next few days. And quite a few of the questions we get are you going to provide the recording? So I just repeat again, the slides and recording will be available on the websites in a few days' time. So. Right, without further ado, let me hand over to Amy Klinger, who's going to provide some more information on this webinar series and also introduce you to the speakers. So thank you, Amy.
Thank you, Emma. I'd like to welcome all of the participants to today's webinar on behalf of the PETA International Science Consortium, and to take this opportunity to thank Chemical Watch for all of their support in organizing these webinars. The goal of this 6-part webinar series is to help registrants plan for the 2018 REACH deadline. Around 800,000 animals have already been used for REACH purposes, and with tens of thousands of chemicals due to be registered for the 2018 deadline, millions more animals are expected to be used in the coming years. However, there are provisions within REACH to minimize animal testing, and for Annexes 7 and 8 in particular, there are excellent alternative methods that can be used to meet REACH data requirements. It's with this in mind that our Science Consortium has made minimizing animal testing for REACH requirements a high priority. If you check out our website, you'll see that we have a page dedicated to promoting alternative methods to meet REACH requirements. And I'd also like to let you know that our scientists are available to assist registrants in avoiding animal testing, so please feel free to get in touch with us if you need advice on how to use the alternative methods discussed during these webinars. Today, the first webinar will focus on the use of QSARs and read-across as one of the core methods that can be used to minimize testing for all endpoints. The later webinars address specific Annex 7 and 8 endpoints, including the next webinar on skin irritation and corrosion, which is on November 11th, and the third webinar on serious eye damage and eye irritation, which is scheduled for December 4th. We hope that you find this first webinar on the use of QSARs and read-across helpful, and that you can join us for the future webinars. I'll now introduce our speakers. Next slide, please, Lorna. Dr. Grace Patlovich is a computational toxicologist at DuPont's Haskell Global Centers for Health and Environmental Sciences, and Dr. Mark Cronin is a professor of predictive toxicology at the School of Pharmacy and Chemistry at Liverpool John Moores University. They're going to jointly present on how QSARs, read-across, and the OECD QSAR Toolbox can help in addressing the REACH 2018 deadline. Grace, Mark, over to you.
Thanks, Amy. So I'm Grace. I work at DuPont, and I'm based in the US. So for those of you on the call that are jointly on the East Coast or elsewhere, good morning to you all. And to those out in Europe and elsewhere, good afternoon to you all. And I'm really thrilled and excited to be on this call giving this webinar today. So Mark and I are going to attempt to provide a bit of a broad overview, and I emphasize sort of a broad overview in terms of some of the possibilities and caveats of using non-testing approaches in support of the REACH 2018 deadline. So next slide, please. Okay. I'm not seeing it yet, but hopefully you're moving on to the next slide. So the context really obviously is the REACH 2018 deadline, and we've got the 31st of May coming up, 2018, and it might seem like an awful long way away, but actually this deadline will arrive a lot sooner than you expect. So having this webinar and really getting on board with what available guidance might be available and what the opportunities are to help address these information requirements that we have is really sort of critical. So the phase-in deadline really sort of impacts substances manufactured and imported at 1 to 100 tons per year, and all the information requirements are kind of detailed in quite some depth in Annexes 7 and 8 of the legal text. And obviously that's going to impact an awful lot of substances, tens of thousands. Next slide, please. One of the proactive things I think that REACH really offers is in its thinking in terms of how we might be able to push the boundaries and exploit the use of non-testing approaches and other alternatives. And really, that's addressed in some of the articles in the REACH regulation in terms of how we can avoid animal testing and using it as a last resort. And also in terms of addressing and bearing the conditions in Annex 11 and looking to see what other means other than animal testing can be used by exploiting both in vitro methodologies as well as quantitative and qualitative structure-activity relationships and using a grouping approach. And what we'll aim to do as part of this webinar is to provide a bit more practical ideas in terms of how you might be able to exploit these types of techniques. So next slide, please. So really the aim of our webinar today is to try and provide this overview, this introduction of how non-testing approaches can be exploited, and really as part of what we term an integrated approach to testing and assessment, or IATA. And really how we can address the information requirements for those two annexes that we need to address for this 2018 deadline. We're going to focus much on the in silico approaches. Obviously, we've heard that there's a number of other webinars that are coming up that are looking at how we might exploit some of the in vitro approaches for particular endpoints. But another aspect that we want to highlight in this webinar too is some of the advances that have been made in the toxicity testing in the 21st century, or Tox 21 field. It may impact some of the type of data that you could generate to support non-testing approaches. It may be that some of this type of information is too new or too novel to do so. But I think it's important that we raise some awareness about what the opportunities might be for how you might exploit that type of information. So really, we're going to try and highlight some of the activities that have been going on in that area to bear in mind and be aware of. So next slide then. So the outline of our talk that Mark and I are giving today is really firstly to present this IATA construct and related terms. Now I know when IATA is a bit of a strange acronym, and it doesn't mean the International Association or Air Transport Association, but really means this integrated approach to testing and assessment. There's a number of related definitions or terms associated with that, so we're just going to highlight some of these just to give you a flavor of what we mean and how that's pertinent for, or how it's defined under REACH. Then we're going to sort of move on and talk about, well, what some of the non-testing approaches might be, what their definitions are, what do we mean by QSARs, what do we mean by chemical grouping approaches, some of the considerations associated with doing a read-across or other data gap filling type techniques. And then we're going to sort of shift gears completely and talk about some of the future directions. So I mentioned in the previous slide sort of talking about highlighting advances in the Tox 21 area, and part of those advances include something called an AOP, or an adverse outcome pathway, and we'll talk a little bit more about what that is and what opportunities might exist to enhance some of the non-testing approaches, or how that impacts the development of these types of IATA. We're going to wrap up with a few summary messages, and then we've provided a few links or suggested publications and other resources that might be helpful, and that's kind of included in a few pages of useful links. So moving on then. Next slide, please. So what do we mean by integrated approaches to testing and assessment? There's this is a term, this is an approach that's been around for a number of years already. And one definition that's provided by the OECD talks about IATA as being a means of organizing and analyzing, what relevant data you might have on a substance or a group of substances, and try and couple that with what information you might have about the exposure, about dosimetry, about the mechanisms, and use that information collectively to decide, do you need to do can you make a decision based on that type of information, or do you need to do some further testing, and what that testing might represent in order to make your decision. So that's kind of one definition of an IATA. In concert then, a related term that's often used is an integrated testing strategy, or an ITS. And this again is a similar term that sort of talks about integrating different types of data and information in making a decision. And that might be using a collection of individual assays or test batteries or tiered testing schemes, or even using all that information as part of a weight of evidence assessment to make a final decision, whether that be a risk assessment one or something else. But in practice, I suppose what you could take from those definitions is, this is all about how do we make the best use of available information, of non-testing information, and using that to determine what new data may need to be generated in order to make a decision, whether it be our risk assessment decision or a classification labeling decision, or any other decision that isn't necessarily related to REACH per se. But it's a generic term in that sense. So next slide, please. So under REACH, we don't tend to talk about integrated approaches to testing and assessment per se, but we tend to define it as integrated testing strategies, or ITS. And you'll see in the available technical guidance, there are these ITSs that are described for each endpoint, and how, in terms of how you can pull together different type of information pertinent for that endpoint in order to make such a decision. I like to think of them as workflows. What are the different steps of trying to gather available and relevant toxicity information on a substance, and doing that evaluation of, is it fit for the purpose for the decision I'm needing to make, whether it be classification and labeling or risk assessment. Some of these ITSs that you'll see in the guidance are really quite complicated. Some are more simpler. But the building blocks in terms of the components of what steps you go through are essentially the same. So it really is about what existing information you might have already for your substance, what data from in vitro alternatives may already be available that you can make use of, what related chemicals may exist to facilitate using a read-across approach, so many of the non-testing approaches, and using all of that together and making an initial assessment of whether that's sufficient for the purpose you have in mind before you start generating any new information, and particularly any in vivo test information. So I think it's very important, and why we've kind of included some of these slides here about ITS is really non-testing approaches, QSARs, read-across, really is a component of this overall gathering of information and making an assessment first, rather than thinking about it as something that's done in isolation. So that's kind of why I've included here, it shouldn't be included in vacuum. We use a QSAR approach, but we want to sort of think about the outcomes in concert with other information that we might already have, rather than just thinking about it on its own. So next slide, please. So what are some of the components? I said that there's many different building blocks. What some of the components or the typical information that you might find within an ITS is really, this historical existing information that you have on your chemical of interest. That could be some quite old studies or old non-standard in vivo tests that you have, or some literature references that you have that describe information for a substance that might not conform to the updated test guidelines, for instance. You could have information from similar chemicals that would permit your read-across approach. You could have predictions from other non-testing approaches, such as those from QSARs or from other expert systems. There's data you might have from in chemico tests, in vitro tests, and even maybe from some of the new generation omics type technologies. And of course, another important aspect is your exposure considerations. So what does an ITS kind of look like in practice? Next slide, please. We've just pulled out one from the REACH guidance in Chapter 7A, which is listed for skin sensitization, just to illustrate conceptually what these building blocks might look like in that workflow. It's quite a narrative, qualitative structure as is represented in the REACH guidance, but at least gives you a flavor of some of the important components to consider. I'm not seeing the next slide. Could I have the next slide? So, okay. And on that note, I think once we get to the next, all right, okay, good, we can see the slide. So the different steps, so that first one I've circled that's talking about gathering the existing information, factoring perhaps other information that might be pertinent in order to make a skin sensitization assessment, whether you would have to do some tests. Maybe your substance is very volatile, maybe it's extremely acidic or basic, and so on and so forth. So it gives you an idea of the sorts of information considerations and what type of information you might have up front for your substance before moving on to look at what new data could be generated before conducting an animal test as the last result. So I'm going to hand it back to Mark, who's going to talk a little bit more about what non-testing approaches really means in practice and give you some flavor there.
Thank you, Grace, and hello everyone. Greetings from a hot and sunny Liverpool. I'd echo Grace and thank Chemical Watch and PETA for organising this and giving us the opportunity to tell you a little bit, to introduce the concepts of QSAR and read across. And if we could have the next slide, please. In the next couple of slides, I'm just going to introduce the topic of computational, which is also called in silico toxicology. And listed on this slide are the main techniques that are used. And I think it's worth, before we go into the specifics of the ones we'll talk about today, which are mainly in red here, we just discussed the whole area. So to me, computational toxicology includes capturing data within databases of existing information, and we'll touch on a couple of those in this presentation today. But there's a lot of information being captured, which is now searchable and freely available. In terms of predictions, we've got topics such as category formation or grouping and read across, and we'll give more detail on that today. And in the next couple of slides, I'll just briefly discuss what a structure-activity relationship is, as opposed to a quantitative structure-activity relationship, an SAR versus QSAR, and the role of expert systems. And also in this area, we're seeing a much greater emphasis and a much greater use of informatics. And this is an area that's going forward very rapidly, particularly in the areas of bioinformatics, which we really need to capitalize on in terms of predicting toxicology, and some great advances in chemoinformatics to capture information and apply it and mine and data search. Related to all of these topics, modeling approaches in biokinetics and applying the previously developed and upcoming models in PBPK modeling. And if we have the next slide, please. This whole area, particularly in terms of computational approaches, this is what we call non-testing approaches. So non-testing data are those that come from computation and understanding and application of our use of chemistry to predict toxicity. And as Grace said, this is one of the cornerstones of ITS and IATA, and is typically where someone would go to first of all to interrogate a database and then to make predictions and to perform read across. In the next slide, please, we just have a simple definition of what I mean by a structure-activity relationship leading to a structural alert. So a structure-activity relationship is taking a fragment of a molecule, a substructure, and finding the relationship between that substructure and a particular toxicity. On the right of the screen, you'll see the classic Ashby-Tennant supramolecule, which was published nearly 30 years ago now, and that was one of the first attempts to define approximately 20 structural alerts, and these were related in this case to mutagenicity. And these structural alerts, it's important to remember nearly 30 years ago they were defined in terms of chemistry. Here we've got a collection of electrophiles. So the functional groups you see have electrophilic capabilities, and these structural alerts were supported by real data which are all in the original publication. So good practice all round in developing these structural alerts. In the next slide we have a simple definition of what a quantitative structure-activity relationship is. So sometimes called QSARs or QSARs, mainly QSARs. And these now, the key word here is quantitative. So rather than just looking for a fragment of a molecule associated with an activity as in an SAR, a QSAR can be a statistical or other type of relationship that's trying to determine relationship between toxicity or ADME properties, or indeed many other types of activities, and the physicochemical and structural properties of a molecule. These have been around for about 50 years, since the seminal work of Hansch in the early 60s, and have been applied in development of pesticides, in pharmaceuticals, and for at least 30 years now in prediction of toxicity. It's important to note as well that the QSARs, typically we think of them as predicting potency, so quantitative endpoints. And there's been some excellent work done, for instance, in ecotoxicity and predicting acute aquatic toxicity. But equally, quantitative models can be used to predict qualitative endpoints such as the absence or presence of an activity through modeling techniques such as discriminant analysis or logistic regression, where we have a series of descriptors used to describe the molecule. In terms of statistics, we're not going to go into detailed statistics here, but suffice it to say, particularly on the QSAR side, they can range from a simple regression type approach through much more multivariate, partially squares approaches, and indeed many applications now of nonlinear multivariate neural networks, support vector machines, and many types of approaches. In the next slide, please, we just define what we mean by an expert system. And the reality is, as many of you as users of QSARs will not want to go and develop your own QSAR and redevelop existing QSARs. Where you'll go is to an expert system which does much of the hard work for you. So an expert system is a formalized system and usually computerized that enables you to make rational predictions of toxicity. Some of these may be found on the internet, some of these are commercial systems, or some may be freely available, and we'll focus on one or two in this presentation here. And the theory is that a user can, once they have this set up and with certainly some expert knowledge or some useful training, be able to draw in a chemical structure and find out the properties and maybe related chemicals to that molecule. There's a number of different types of expert systems, and some are based on what may be thought of as the traditional equations within QSARs, so empirically based algorithms. TopCat from Acceleris is one of those systems. Others have attempted to capture knowledge through structural alerts and the understanding of structure-activity relationships. Derek Nexus from LASA Limited is an example of that. And there are also systems that are hybrid of both of those. So the Times SS system and Oasis from LMC in Bulgaria is an example of that. And there are many other systems that are available as well. We just mentioned those as good examples of that system. Okay, I'm going to hand over to Grace again now, and she will address the regulatory application of QSARs.
Okay, so we've got a number of regulatory applications that QSARs can be potentially applied for. I like to think of QSARs as being packaged mature information for systematic reuse, and that just means, well, we've got a lot of information that's captured for many different substances, and we're able to harness that and exploit it to make estimates for new substances that haven't been tested. If I could, all right, okay. So you can use a QSAR, for instance, to provide an estimate for a given endpoint, whether it be toxicity, effate, or physchem, in lieu of doing a testing. And we might sort of say that's, in terms of a data gap filling, that could be to replace doing that testing, or you might use it as supporting information as part of a weight of evidence type of approach. You might use a QSAR to substantiate a waiver that you're writing. Say you're writing a waiver that something is not going to hydrolyze or is going to hydrolyze. Maybe you'd use a QSAR to provide another line of evidence to support that line of reasoning. Or you might have some data that looks to be some type of outlier. Doesn't kind of make sense, and maybe a QSAR can be helpful to rationalize that particular experimental result that you already have. I like to think of QSARs as being particularly helpful in category development and the associated read across, to provide you with that type of chemistry-based or mechanistic type of information to justify, why are two or more substances really sort of similar, and use the information that might be encoded in a QSAR to help make that leap. So under REACH, we can use QSARs to fill particular data gaps. Next slide, please. And if you look at a lot of the different endpoints that we need to address in Annex 7 and 8, many of those actually readily lend themselves to QSAR use. So for example, you could use QSARs to provide your lethal concentration or effective concentration estimates for some of the aquatic tox endpoints. Particularly for things that might be kind of difficult to test if you've got a gas, for instance. There are good QSARs available for making predictions of some of the physchem properties, like log KOW, the octanol partition coefficient, or for the absorption coefficient. And I think there are a number of QSARs, and some of the expert systems that Mark's already referred to can be quite useful to provide supporting information for endpoints like mutagenicity or skin and eye irritation or sensitization, to name just a handful. Obviously, there are a number of conditions that we need to meet to satisfy use under the REACH, and we have to provide specific documentation. And I kind of want to outline those in the next few slides just to illustrate what that might represent. So next slide, please. In Annex 11, we've actually got some text that sort of talks about how we can use results from what's known as valid QSARs, valid quantitative or qualitative structure-activity relationships, to indicate presence or absence of a certain dangerous property. And I think highlighting the presence or absence is pretty critical, because often we might think of, well, we might just use a QSAR to provide a notion of whether something could be toxic, but not vice versa. But under REACH, we can use that type of information instead of testing, so long as you meet these sort of three conditions. So you have to have a valid QSAR, and validity makes reference to something called the OECD Principles for QSAR Validation that I'll highlight in a following slide. We have to have the substance that you're trying to evaluate using that QSAR. It's got to be relevant for that QSAR. So we might talk about something called the applicability domain, and again I have a slide to to talk about what that really means. But you need to have a QSAR model that's applicable to your substance that you're interested in evaluating. So you could have a really good QSAR, but it doesn't work for your particular substance because it's out of scope, and therefore that wouldn't be. Oh, please go back. That wouldn't be a relevant QSAR result. So if you have the intersection of those two, that would be constituted a reliable QSAR result. Obviously, there are many different QSAR models available, but you need to have one that's relevant for the endpoint that you're interested in addressing the information requirements. So it needs to be pertinent for a regulatory purpose. So the intersection of those three then means you could have an adequate QSAR result, and that information from the prediction that you generate, as well as the model itself, that needs to be documented in particular formats. And again, we'll talk about what those look like. But so next slide, we talk about having a scientifically valid model, and that really makes reference, as I say, to these OECD principles. And some time back, a number of discussions, at meetings and finally at the OECD, we rationalized these 5 principles that a QSAR ought to be associated with if it was going to be used for a regulatory purpose. Namely, that you'd have to have a defined endpoint, an algorithm that was unambiguous, so you could understand the methodology or the principle by which a prediction was being made, a definition of what the scope of the model is or its applicability domain, and some measure of its performance characteristics, such as the goodness of fit, robustness, and predictivity. And ideally, if you could provide some kind of mechanistic interpretation to be able to appreciate or understand what that means in the biological context of the prediction that you're making. So these all represent principles to assure validity. Now, I know we're not talking about validation per se. We're talking about having a valid model. And this also doesn't necessarily mean that you need to have a QSAR that checks all these different boxes, because that, again, will depend on what information you already have and how you're going to use that QSAR result, whether it would be for filling a data gap as a replacement value of or as supporting information. So I think these are kind of quite important considerations. There are other considerations or other practical considerations for QSAR use, and that's listed on the next slide. So can you recreate the QSAR model? How transparent is it? Do you understand what is in the training set, what descriptors were used to develop that model, just to get a flavor of can you at least address those principles by what information that exists in terms of how that QSAR was developed? Can you extract, if there isn't a domain defined, can you extract a domain? Is there sufficient information provided in sufficient transparency to enable you to define a domain and therefore be able to sort of demonstrate how your substance falls within the scope of the model and how to justify your prediction that you make afterwards? And what other information that might exist for your endpoint anyway, that would help determine how you might use that QSAR result, whether it would be a replacement or part of a weight of evidence assessment. So what do we mean by applicability domain? Because that's a critical one in terms of the principles for QSAR use and in terms of justifying the validity of your prediction for a given purpose. So next slide, please. There's many ways in terms of assessing or defining an applicability domain and making that assessment of whether that model that you have, that QSAR model, is going to be useful for your particular substance. You could define an applicability domain by the descriptors that were used to define the QSAR model to start with. It could be on the basis of structural features, whether those be structural fragments like those that Mark already alluded to in terms of the ZARs. It could be on the basis of some metabolic transformation or some other mechanistic information, all of which might be captured in some form or shape or other in the QSAR itself. And these are really important considerations, but there are actually some tools that might help you define and assess an applicability domain so you can at least meet one of those conditions for QSAR use. And we've kind of provided here just a couple of examples. There's the ambit discovery that was funded in part by the CEFIC LRI that's available from, we have a website address in the useful links where you can access more information about that one. There's also the domain manager that the Laboratory of Mathematical Chemistry sort of develops that also enables you to extract different domains from a given training set in order to provide that kind of assessment of whether your substance falls within the scope of that domain. In terms of documenting all that information, on a previous slide I showed that there were particular reporting formats or templates to use to satisfy the requirement of adequate and reliable information. And on the next slide, please, we've listed here what a QSAR model reporting format looks like. And this is really a harmonized template that outlines specific information that you ought to provide to document and justify a QSAR model. And really this is built around or framed, it's underpinned by the QSAR principles for QSAR validation. So really those same principles, but just outlining in easy steps what type of information we're looking for in terms of adequately characterizing a given model. There's a free editor that you can download from the JRC website, and that can facilitate filling in that type of information. And you can even upload a completed QMRF and submit it to the JRC's model inventory. And again, we have some more information on that in the useful links. In contrast, then, we've also got to provide some information to document the prediction made from the given QSAR model, and that's listed on the next slide, please. And this is, again, also based on the OECD principles, but really a harmonized template to summarize substance-specific information that's being generated by the QSAR model. So you need to provide some information. What is the substance that you actually making a prediction for? What is the endpoint that is made the prediction for? And why you believe that prediction is reasonable and robust in light of the model that you've used to generate it. And again, more links in terms of what a completed QPRF may look like. And again, there's more information in the guidance document in Chapter 6. Next slide, please. In terms of our own experiences of using QSAR approaches in this manner, I think it's fair to say that QSARs are most promising for some of the physchem and ecotox and EFATE type properties as these replacement values. Next slide, please. There's also been a lot of progress, I would say, in the area of gene tox. So there's many models available to predict Ames mutagenicity should you wish to make a prediction. No, go back one, please. Make a prediction for Ames mutagenicity and to a large extent on skin sensitization. Within category approaches and also as part of a weight of evidence, I think there's been quite a lot of progress in terms of using QSARs for skin and eye irritation and also for some of the other gene tox endpoints that we need to address as part of Annex 7 and 8. But I would say for repeated dose toxicity endpoints or repro-developmental endpoints, progress, well, we're not there yet, and there's a number of reasons for that, which we'll allude to later, but they can play a useful role in supporting a read across, but you wouldn't use a QSAR model that's been designed to predict that type of endpoint, as certainly not as a replacement for doing some other work or some other strategy. So they can play a useful role, but they're not sufficiently involved to use for replacements. On that note, I'll switch over again back to Mark, who will give you more of an overview of the idea of grouping approaches and read across.
Yes, thank you. I'll just give a quick and very brief overview and introduction to grouping, forming a category, and then for allowing to read across toxicity where possible. And this has really come to the fore certainly in the last year or two, and we're reading and understanding a lot more about this. And some very quick definitions here. on this slide. The first is that an analog approach in terms of what we're discussing here refers to groupings based on a very limited number of chemicals, often simply a target substance which you want the read-across prediction and a chemical with which you have data. A category can be slightly larger and is used when we have more analogues and possibly 3 or more members, and there may, in this case, in a category be a trend. So you may see a range of potency, and even within categories and groupings, some range of activity on a qualitative approach. The process of read across itself is that of making the prediction to allow for filling data gaps using either the one-to-one analog or within a category approach. And in the next slides, we have a very commonly used and often seen diagram of this, and just to explain again, you will see this diagram very often. For instance, if we take property 1, we can assume that read across in an analog situation is from chemical 1, for which we have a data point, to fill the data point in chemical 2. And it's important to note the concepts expressed for property 2, where we're interpolating an activity where our read across our chemical falls between in our area of chemical space, chemical 1 and chemical 3, as opposed to extrapolation where for property 3, where the target chemicals may be outside of the area of our category. Clearly we prefer interpolation, and property 4 intends to show where you have a trend analysis or a QSAR where you have a series of properties for some chemicals. In the next slide, we've just briefly summarized the REACH workflow for categories. This is taken from the ECHA guidance, and now we're moving into the how do we form a category or identify an analog question. I don't have time to go through this in detail, but suffice to say the first step 0 is to determine whether we have an existing category, and I'll discuss that in a moment, how we can define that, and that may be sufficient for category formation. If not, or if you wish to redefine the existing category with new data, then there's a series of steps, and we'll talk about forming a category hypothesis and defining the category, gathering data, providing evidence in terms of evaluating the adequacy of the data, constructing the data matrix, and then in step 5, perform a provisional evaluation of the category and read across, possibly even using QSAR analysis to fill a data gap. Within the ECHA guidance there is provision for proposing and performing testing, and we'll also deal later, if we have time, on the category reporting format, the documenting of the final category and why you feel it has evidence. In the next slide is just a summary of some of the considerations before you even get to that workflow. And really, you shouldn't go to the workflow or consider read across until you've mapped out in your own mind how many data gaps you're filling and for which endpoints. This will really direct how you do the read across and category formation. Key to all of these approaches will be access to data, and you'll need to decide which data you have access to. Are you going to rely on the public databases or other databases? And then before you start the process again, some hypothesis about grouping the substance and whether it's possible, and this falls into the AOP type framework, to substantiate that hypothesis. And again, the next couple of slides will explain that. The other questions that you need to consider relate to whether the data are fit for purpose, the confidence that you'll need, and so, for instance, for prioritization as opposed to classification and label and risk assessment, and also the consequence and what might happen, the cost elements of read-across approach not being accepted. So taking one of those, the key one, in the next slide, please, we can consider the types of groupings. And this slide summarizes 3 of the main ways of grouping a compound. and forming a category. The use of structural analogues is by far the most frequently used, and here we just have a simple congeneric series. So we have the same functional group, in this case just varying in chain length and carbon chain length. More complex, but possibly useful for some endpoints, is the use of mechanistic analogues. Here we have 4 compounds that are known to be skin sensitizers by the same mechanism of action, and it's an electrophilic mechanism of action, and the functional group in red is the hypothesis and the means for grouping here. More complex still are the use of so-called modes of action analogues, and this is something possibly for the future and for the chronic and reproductive toxicity endpoints. Here you have 3, you have the estradiol and 2 estrogen binding mimics. So here the purpose is to group on potential modes of action. In the next slide we also summarize that within the REACH guidance and the provided by ECHA, there's provision to group compounds that can be metabolized to a common molecule and those substances that are degraded to a common molecule. And obviously your reasons for grouping firstly must be rational, but could include any of those or even more than one of those potential types of groupings. So in the next slide there's some suggestions on where you might go once you have your target molecule, a hypothesis, where you might go to find structures to provide potential analogues, hopefully with data. That may be within a company from your own inventory or some inventory you're familiar with, or some of the computational tools that are listed there. I'm going to give in a moment a quick illustration with the OECD QSAR Toolbox. There are other tools to find analogues. ToxMatch works on similarity, ToxTree on structure alerts, ChemProp on alerts and atom-centered fragments, and so forth. Some of these methods are freely available. Some, there may be a charge element to them. And in the next slide, I'm just going to briefly introduce the first of those methods, which is the OECD QSAR Toolbox, which is somewhere where many of you will want to go to find information about forming an analogue and grouping and performing read across. The OECD QSAR Toolbox has been developed by Laboratory of Mathematical Chemistry under the supervision of Professor Avanis Makenyan in Burgas in Bulgaria. It's freely available, and it, as it says, facilitates, it allows you to develop, evaluate, justify and document categories to make read-across predictions for a large number of endpoints. It's been designed, as we'll see, that it mimics and allows the user to follow the OECD and REACH guidance on forming categories, and contains many inventories plus data and means of grouping compounds. And those means of grouping compounds are commonly called profilers, and there are many associated, for instance, with DNA binding, protein binding, as well as for endpoints and mechanistic approaches. The examples I will show you in the next couple of slides relate to version 3.2 of the Toolbox, and if you're interested in downloading this, the URL is at the end of this presentation, and soon in the next month or so we're anticipating version 3.3 and ultimately version 4. And finally, the Toolbox is leading the way in implementing AOPs. So in the next slide I'll just briefly give an overview of the question you will first ask: is your substance already a member of an existing category? And here there are 2 places you can go for the high production volume categories. One is the OECD and existing chemicals database, the first URL, and that's shown on the right, and that has approximately 120 categories within it. The second URL is the US EPA's high production volume information system, and that has information on over 900 chemicals taken from the high production volume challenge. So that's the first kind of place that you may go to search for existing categories. In the next slide, indeed the following slides, we have some screenshots from the OECD QSAR Toolbox. And again, I must add, this is a very, very brief overview. The Toolbox is a complex piece of software, and you would be interested, as well as downloading the Toolbox, in the training that goes with it. There's videos, slideshows as well. And indeed, as well, I should add, there are training courses, and there's details of one of those at the end of the presentation. Here, one of the first questions you will ask, one enters the substance, and here we've put in ethylene glycol methacrylate, and we've identified that as belonging to, in this case, the OECD HPV chemical category of multifunctional methacrylates. So that's answered our first question for us, that it does belong to an existing category, and we can use that for read across. In the next slide, we have a different example using hexanal, and here we've entered the structure into the Toolbox. In the next slide we show how for that chemical it can search the database. The Toolbox contains many databases of human health, mammalian and ecotox data, and is actually a very good place now to go to retrieve data. So one of the first steps is to determine whether there are existing data that may be suitable for the purposes in which you're looking for. So no further action or work would be required. In the next slide, we just briefly demonstrate how the substance can be profiled. The profilers, here on the top left, we have a series of profilers for, in this case, carcinogenicity and mutagenicity, and they've been applied. And for hexanal, you'll see on the bottom right, a series of effectively structural alerts that can be used as a rational basis for forming a category. And in the next slide, we'll see that a category has been formed on the basis of its ability to bind to DNA, the fact that hexanal is a shift-based former, and the OECD QSAR Toolbox is able to find from its data sets and inventories compounds that contain or are able to act by the same mechanism of action, and where possible, data for that endpoint that you're searching for. So in the final slide of the just brief overview of the QSAR Toolbox, here we show the data gap filling through the use of read across, and the plot is a distribution of the data within this category on the basis of log KOW, log P, and the red circle indicates the nearest neighbours to our target chemical, which is in bright red, the nearest neighbours in the maroon colour, and the prediction here is for gene mutation of the compound being negative. Directly above it, you will see that one of the nearest neighbours is actually a positive compound, and clearly in your understanding of the category and read across, you would want to go and investigate why that may be and evaluate that in terms of concern. So that's a very brief overview of category formation and use of the OECD QSAR Toolbox. I would recommend the training, and I'll pass over now to Grace to tell us a little bit about how to use the results and interpret the results of a read across.
Thanks, Mark. So under Annex 11 again in REACH, we have some guidance there in terms of how we can use grouping and read across approaches. And I wanted to draw attention in particular to the bullet that talks about adequate and reliable documentation, which also was mentioned in Mark's slide of the workflow of how grouping approaches are formulated. So in terms of adequate and reliable documentation, next slide please, there are other templates, a bit like the QMRF and the QPRF. This time we have a category reporting format, and there's also an analog reporting format. And this is really quite helpful in terms of what sort of information to include in providing your detailed rationale and justification for why you can form a group in the first place, and how that might pertain read across for the different endpoints that you're covering. I've listed some of the information that's articulated in the reporting format, but I would add a caveat that this document isn't particularly trivial to prepare, and obviously the OECD Toolbox and other tools are quite helpful in terms of fleshing out that to provide some of the information that needs to be included in the reporting format. So one aspect then might be trying to rationalize the endpoints and why read across is pertinent in each case, and providing the validity of the grouping for that particular endpoint. And here's where sort of some of the QSAR results or some of the QSAR models can be helpful in making that type of determination, or using some of the profiling information that exists in the toolbox, again, can be quite helpful in terms of rationalizing the similarity of substances. So if we go on to the next slide, I've just listed a few things here where we talk about, you might have an overarching rationale, as Mark's already pointed out, in terms of the types of groupings. And we might do an evaluation of the analogs that we've chosen as part of that grouping on the basis of what we understand about the chemistry, its reactivity, its bioavailability, or the likely metabolism. And then for each endpoint in turn, here's where the QSARs can be helpful in terms of rationalizing why that read across might be appropriate or reasonable for each endpoint in turn. And obviously that will depend on the availability of good QSAR models for those endpoints, or what other information can be included to substantiate why a read across for that endpoint is reasonable to do. Next slide, please. So there are particular QSARs that might be helpful, that give you some pointers about how to justify the similarity. For acute oral, there are certain considerations one might include in terms of rationalizing a read across for that type of endpoint. Again, for acute dermal, there may not be any QSAR models per se, but we can make use of those that could exist for oral toxicity and combine that with information we might have for skin penetration and concordance with oral results. There are some models for acute inhalation for volatile substance in particular, and we might be able to make use of that in terms of rationalizing some information for to waive doing an acute inhalation test. There's quite a lot for skin and eye irritation and for skin sensitization and so on. Next slide, please. But for some endpoints, like carcinogenicity or reproductive development, where I've already alluded that there are some models, but they're not sufficiently evolved to be used as replacements, or even for repeated dose toxicity, there are models existing that purport to predict lowest observable adverse effect limits, but they're not really all that sophisticated to estimate likely target organs or anything all that detailed that you would need that would be sufficient for a replacement value. So read across for these types of endpoints arguably can be prone to a lot of uncertainty, because you might want to use a QSAR result to help craft your argument for why two or more substances are similar, but realistically, can you really relate a structure to such a complex and downstream endpoint with any reliability? And that sort of begs the question of, next slide please, our overall current approach for non-testing development and application. Some models, especially for those type of endpoints, aren't particularly mechanistic in nature, and we can't really make predictions with any strong confidence. So it begs the question of, is there another way of doing things? And that's why I'll move back to Mark again, who will talk a little bit about the ALP construct and how that might be helpful going forward. Next slide, please. And back to Mark.
Hi, thank you. Yes, I'll give a very brief overview of the AOP construct, and the AOP offers and provides us with the means of organizing information as far back from the source of the chemical through exposure, through the initiating events, and the series of key events that lead to the adverse outcome. It's become very popular in the last year or two as this means of organizing information, and this slide shows many of the types of information that can be included, from the chemical properties, which will control the MIE immediately below, the molecular initiating event, through the key events, which are noted as KE1, N-1 up to N, through to the adverse outcome. And these are organized according to interactions, responses at the cellular level, organ level, organism level, and population responses. So it looks in this simplistic form as a linear relationship, but actually we appreciate that it's very non-linear, and these will form networks of many interrelated effects. And the next slide, please. The AOPs will become important because they are a means of organizing information based around the mechanism and mode of action. And for us as modeling and to allow read across, they provide a direct linkage from chemistry to the adverse effect and the justification for doing that. We also believe that using the AOP will provide evidence and to support read across, and data from the key events identified within an AOP, so assays for key events, will help us define the domains of molecular initiating events and the domains. And as we'll see later on, they will also inform ITS and IATA. In the next slide, we just briefly summarize how non-testing approaches are developed. And we can see a number of roles here for the use of QSARs or models in understanding the roles of the parent chemical in terms of its speciation and whether it's metabolized, then also the relationship between parent chemical and initiating events. And more downstream, following the initiating event and the adverse outcomes, we see the direct role here for systems biology and systems toxicology. In the next slide, we'll just have a screenshot of how the AOP has been implemented in the OECD QSAR Toolbox. And here we have an example for methylquinone, or a chemical oxidized, auto-oxidized to methylquinone. And the AOP here is for skin sensitization, which is the first AOP implemented into the QSAR Toolbox. In the next slide, as you open up the Toolbox and open up the AOP functionality, you can see what it basically replicates, in this case the OECD AOP for skin sensitization, and links to it at different levels of organization the data available for it. So we start off with the chemistry in terms of binding alerts. At the second level are in chemico data for reactivity, followed by keratinocyte activity in vitro and in vitro dendritic cells, followed by in vivo data for the local lymph node assay and guinea pig maximization test. So this is now going to give us further confidence in being able to support what we understand by category formation and read across. So in the next slide, we have just a summary of that, and I think I've covered all of those points. So I'll just go on to the next slide, and just to say that the AOP is a very important way forward in 21st century toxicology. The OECD has already published the AOP for skin sensitization, and those of you, many of you may be familiar with the work in the AOP knowledge base, supporting the AOP wiki and Effectopedia to capture this information. And one of the key uses we foresee of the AOP and the knowledge that will be derived from the AOPs will be to support read across, firstly through that linkage of chemistry to adverse outcome, but also in supplying and understanding and providing the information from the assays of the key events associated with the adverse effect. So I'll pass over to Grace now to finish off and tell us more about how AOPs can inform testing strategies. So if you can unmute Grace.
Thanks again. We started off the slides talking about IATA and how they are these workflows, and one could envisage in the future perhaps an IATA that's informed by an AOP. So we had a workshop earlier in the year that sort of talked about this, and you could imagine a conceptual flow where you want to develop an IATA, you understand whether there might be an AOP that's applicable for a particular regulatory application of interest. If there is, look at what existing information and data you have for your substance, and then work through that toolbox to see, based on those different key events that Mark's already referred to and exemplified with the skin sensitization, how do we integrate all that information together to make a decision on how that might also impact improving the AOP that already exists. So in the future we could imagine something along this nature for developing IATA in using AOPs. So to summarize, next slide, I think it's fair to say that REACH 2018 is coming up fast. It represents the significant task of having to compile a lot of information for Annexes 7 and 8 for a large number of substances. But we have a number of opportunities afforded by Annex 11 that enables us to use adaptations prior to doing any experimental testing, or at least experimental in vivo testing. And considerations might include, have we registered that substance? Has it been already registered by somebody else? So there might already be a dossier that can be used. Are there promising analogs that can be used to explore a read-across approach? How many data gaps do you have, and for what endpoints? And that will help evolve your practical strategy of whether you use QSAR's grouping approaches or a combination of both in terms of addressing those data gaps. Next slide, please. I think QSARs perhaps have been most effectively used so far for ecotox, EFATE, and PhysChem endpoints, at least as replacement values and as supporting information for what I'd call simpler endpoints within an IATA construct. If we're using QSARs, we have to think about the OECD principles to demonstrate validity of the QSAR model and the prediction that it makes, and document those in a QMRF and a QPRF. For more complex endpoints, such as a repeated dose 28-day study or some of the developmental screening tests, a grouping approach is likely to be more effective, but very critical to have the overarching hypothesis and some evidence to support a read across in that sense. And QSARs can be quite helpful in providing some of the evidence, or at least the information that exists within the toolbox and elsewhere. And as Mark has shown us, in the future, using TOX21 approaches, particularly the AOP construct, next slide please, offers some opportunities and prospects for how we might generate different type of information that's more mechanistic, and that again will facilitate and enhance the type of read across that we can do. It will also have implications for how QSARs will be developed in the future. We've shown that there is an AOP for skin sensitization, and that's been successfully implemented into the toolbox, and that provides an example of the step change in terms of doing read across enhancement. And I hope that the links we provide may be helpful, although they're not exhaustive, but they might be helpful to provide some additional information of where to go for more information about software tools, guidance, and other references. And finally then, we just want to acknowledge several people that we've engaged with over the years. Next slide please. including Gil Vive, Terry Schultz, Bob Diederich, Avanis and his team, and members of various trade organizations, including ESITOC and CEFIC, and also work that Mark's been involved in under the Cosmos project and other 7th framework projects. Next slide, please. In the interest of time, because we've run over, we have 3 pages of links that we can refer to elsewhere, and Mark's already mentioned that there is a training course coming up for the OECD Toolbox later on in November that may be of interest too. And we have links for further information and registration. And on that note, I'd like, from my perspective, to thank you for your attention, and if there's time, take any questions.
Great, Mark. Thank you very much for running through that. It was a great presentation on read across, and it's a shame we haven't got longer. Like you say, we have run over a little bit, but I think we'll have time for some questions. We've had some good ones in. So this is Emma from Chemical Watch again. I actually had a little question I'd like to slip in first, if that's okay. I'm aware that ECHA itself is developing some kind of support for read across. I think they're developing some case studies of best practice and some guidance like that. I don't know if we've got anybody from ECHA listening that can tell us when that might be available, or if Mark or Grace have any information on that front, on either that kind of guidance from ECHA or more generally examples of best practice that could help companies. Grace,
I think that's something still evolving in a way. I'm aware at least of one illustrative case study example that ECHA have published on their website, and we're remiss because we haven't included that in our useful links. We had a workshop with ECHA a couple of years ago that they organized in conjunction with CEFIC LRI, and there's quite a lot of information that's posted there in terms of some industry experiences, but also quite a lot of information that ECHA made available as far as their read-across assessment framework, and that starts to give a flavor of what are the considerations or thought process that they will go through in terms of evaluating read-across cases going forward. And I think that would be we've made reference to it in one of our slides, but I think that would be a worthwhile resource to look into, just to get an idea of what sorts of things they're looking for when evaluating a particular case.
Yes, and that does link to one of the questions we've had in, which, it's talking specifically about mutagenicity, but it's asking for your experience in what's actually accepted by the authorities with regard to that endpoint with and QSARs. Is that something
it's kind of a very difficult question to answer from the point of view of, I can say that, whatever guidance is available, we'll make use of and try our best to pull together using QSARs and read across to address different information requirements and including mutagenicity endpoints. But it's because of the way that dossiers are evaluated for compliance, one never quite knows whether your dossier has been evaluated yet or not, or what the outcome has necessarily been. So you're often working in a vacuum in terms of knowing whether your strategy is actually worked out in practice or not, and I think that's kind of a challenge for everybody.
Yeah. Okay then.
Yeah, just to add to that, I think one of the key challenges clearly is justifying how you form the chemical grouping and the rationale for that, and I mean, for mutagenicity, certainly the in vitro effects, then there is good evidence provided for that, and also how we can support that in terms of providing further evidence to support category membership to allow for read across. Just to plug some work that is ongoing within the SURAT 1 research initiative, which is the European Union research projects co-funded by the Commission and Cosmetics Europe. There are, at the moment, a number of case studies just starting in terms of read across, which hopefully again will provide some illustrative examples of how we can do read across better and support categories and grouping, and also link that through to the AOPs and make some suggestions about how information from particular assays may help support grouping. But I agree with Grace, it's an extremely difficult problem, and it's a process of justifying your grouping and therefore read across.
Okay then. I've got another question here. I don't know if you want to take this one, Mark, first, and I don't know if Grace has an opinion as well. But it's quite a short question, I think. What kind of expertise is required to use the OECD QSAR Toolbox?
That's a very good question. I've been involved with the Toolbox for many years now, and I think you need a mixture of expertise. I think you do need to accept it requires expertise to use it, and you should take time either to go through the training material or attend one of the courses. But you certainly need expertise or knowledge in chemistry to make sure your chemical structure is correct. You also need that knowledge to understand the roles of the tautomers and the oxidization, and also possible metabolism. But as well, the chemistry is implied or required for the profiling and creating a reasonable category. But on the other hand, you also need considerable expertise in toxicology to interpret the results, to interpret the data that you may be using and you may be applying, and also to interpret the principles behind category formation and therefore read across. And ultimately, of course, depending on how the context in which the read across may be used, whether it's for prioritization, classification and labeling, or risk assessment, you do need that regulatory background for the application of the knowledge. So I've struggled to think what is the ideal background coming into this, but it is certainly a mixture of expertise or being able to call upon experts with the relevant expertise. Grace, do you have anything to add?
I would echo what you have said, but I'm happy that you mentioned you might have to call upon different experts to help you, because I don't necessarily think that one person can do it all. I have sort of more of a background from chemistry and some in toxicology, but I lean on people quite extensively to. It's more of a team-based effort in terms of when we use the toolbox, but in terms of structuring the overall category reporting format, that's kind of drawing on a multidisciplinary team.
Yeah, and I guess thinking about the 2018 deadline with the expectation that there'll be many more smaller companies registering substances, would you envisage that they would be very much looking for outside help and support to construct these, their justifications and their doing read across?
I would imagine, yeah. Again, it's taken many of us a long time to really appreciate the complexities of category formation, let alone the use of the toolbox, which does require, as I say, quite a lot of training. So to be able to apply all of these tools successfully without considerable expertise will be a challenge. So clearly there are many who will have to go to outside expertise to get more knowledge.
Yeah. Okay then, I've just got a couple more questions which hopefully we can answer quite quickly, because I think we're going to have to wrap up fairly soon. But one of the questions I've got here is, how can we find out whether our chemical of interest was used to develop a read-across algorithm? Are there just a matter of checking through databases, or?
Well, it depends really what is meant by read-across algorithm. So if you're talking about a QSAR approach, then yes, you would have to look at the training set particularly to see whether it was included in the chemicals to develop the model. That's assuming, of course, you can have access to them. And that's an important point in understanding transparency. In terms of read across, then implicitly a category should be stated. So the chemicals within the category should be available and visible to you and transparent to you. So it's just, again, a question of ensuring whether your chemical is in that category. Many of the pieces of software that you'll come across, if you put a chemical in that it knows about and has data for and is in the training set, then it will identify it in that way, so it will automatically tell you. Otherwise, yes, it's a manual process of checking whether your chemical's in the training set.
Okay then. Last question, which I think this is going to be a yes or a no answer. I don't know, but there's a question here about whether or not you can use QSAR to deal with UVCB substances. So that's those substances that are they undefined variable. They're ones that have, I guess they're difficult to define, aren't they? So I can't remember exactly what UVCB stands for now, but.
Yeah, it's mixtures of variable composition.
Yeah.
We're beginning to apply QSARs to this area. Implicitly, from an ideal perspective, you need a single chemical structure to go into a QSAR to make a prediction, particularly in the Toolbox and some of the new additions you will see coming into the OECD QSAR Toolbox. There is provision to look at mixtures. So I think my answer would be, and Grace can comment herself, we're not very good at it at the moment. There is considerable research, I believe, going on in this area, and we need to consider how we're going to do this. So it is difficult at the moment.
Yeah. Okay then, I can see there's been quite a few questions coming in during the Q&A session. As I said, I think we've probably run out of time now, but we'll look through all these questions and maybe try and get some responses up. To say you can post them to the to our forum, which I think you can see the link there. I can't see the link, Lorna, but there we go. So there's a forum there where you can post questions that haven't been answered. But I think the number that's been asked, we could possibly get a Q&A together to send out to participants in the next few days, maybe when the recording's available or shortly afterwards. But okay, we'll let you know about that anyway. I'd just like to wrap up now and say a big thank you to our speakers and also to PETA International Science Consortium and also to all the delegates as well for participating. We've had about, I think there were over 800 people that were signed up, and I know over 450 were listening at one point, so that's good news. Just to wish you all the very best of luck in dealing with this complex area. Thank you very much, and goodbye.